Hello, everyone. Can you all hear me? So, seeing a lot of faces from college, from entrepreneurs. How many of you are entrepreneurs or working in the industry? Great. I hope you enjoy some of the tools and technologies what I talk about. So, not further delay. We have very limited time. Let's move. Yeah. So today we will cover how we go about digital transformations or data transformations using cloud, as well as I will talk about some of the open source tools and technologies that we can directly integrate with Google Cloud. We have frameworks which can scale and gives customers a better experience in terms of latency, or you would say the best user experience. We have explainability and ethics. And coming into that, I will try to explain as much as possible, given the limited time we have, as well as sustainability. We have some of the use cases we will see during the COVID, which has helped our customers or industries to use Google Cloud as a part of their transformation journey, and importance of sustainability, as we have talked about. Now, going to the first thing, the data transformation journey. Yeah. So in terms of taking a quote from Tim O'Reilly, founder and CEO, every industry and every organization will have to transform in the next few years. Think about the energies and utilities vertical, which is lying far ahead, far beyond, lagging behind in the transformation journey. Yes, in banking industry, healthcare industry have started their transformations. What is coming to us in the next decade is much bigger than the original internet that you understand it. Get on board with it and figure out how you transform your businesses. So are we all set? So now, if you think about startups, we may be at the beginner or opportunistic state, or we think about very legacy companies, oil and natural gas. They have huge data. They don't know what to make use of that data. Then we have the foundational journey, right? Organizations have started understanding the use of data. The beginner, entrepreneurial mindset, I will do something out of analytics, CRM. We have been exploring this. We have integrated SAP, BI tools, and others. Now comes the foundational step. I will build my data capabilities with data scientists and engineers. We need to know ETL extraction, data proc. We have talked about data transformations, loading tools. We need to know about how the cloud data storage or the warehousing works. How do we integrate, how my data scientist works hand in hand with data engineer as well as the analytics team. How do we deploy on-premise versus cloud versus hybrid systems? Some of my customers want that I build them the same capabilities as Google Cloud in their premise. They will have a network where there will be some of the data will be running inside their systems, inside their network, and that will talk with Google Cloud. What are the tools and technologies available? How we are establishing direct peering, dedicated interconnect to transfer huge volumes of data from my on-prem systems to the Google Cloud. Then we have differentiated. We are bringing in AI ML solutions. We have to be strategic to acquire more customers. We use Vertex AI. We start using Vertex AI. We start using monitoring tools. And at the end, transformative. So I have to be built, as a CEO, am I taking the right steps to make aware my people that I am using the best practices? I'm concerned about the environment. Am I using Google Cloud to ensure that my organizational roadmap is aligned and I'm not emitting carbon? Am I taking initiatives that encourage to have all the metrics listed for each and every data, say calling the APIs or involving any machine learning, that I am very much concerned what is the exact carbon emission per lines of code? Am I doing that? Transformative. Something happens like the pandemic. Does my system is equipped to detect the model drift, data drift? What are the changes that have gone in? Banking industry has seen a tremendous change in the pandemic. Why? All the older models that were working before that did not give the same results as we moved on to the pandemic. The entire data schema or the data pattern changed. So do we have those tools in place? Yeah. So what we are using, cloud scale performance. managed services, as well as enterprise-grade support. And we can see that how leaders and all others have come together in democratizing data and AI with Google Cloud. Rapid iteration, we are checking all those vulnerabilities, all those things will come in: privacy, fairness, sustainability, and how as a CEO or as a leadership team, I'm encouraging my team to follow those practices. Yes. So we have seen, we will go into few of these steps before going into the tools. So no more isolated data lakes. Are we using the right tools to connect those entities or components? Are we having the tools to discover the metadata? How we are doing that? Dataplex, Google Cloud will help you to do that. We'll talk about data catalog. We are moving into the next decade of transformations with Bitcoins. We have enterprise data management. No more centralized, we are also moving into decentralized systems using federated learning. And we have the right hybrid security tools in place, differential learning. Then we are discovering new business terms, glossaries, data catalog will come into place. Feature stores, search about Google Fist. I have not put the demo here, but we can talk offline. How does Google Fist help you to create a feature store? Apply the changes and collaborate with your teams. So you may be working in one unit of your business unit, other unit needs collaboration, sharing of features, so that we are not doing much work. Reuse our own features, reuse our own models to create ensemble models. Plug them in. Use Google Feast. Yeah. Cloud Run, we have already discussed. Go serverless as much as possible. We will see how it helps in sustainability, maintaining the sustainability metrics. Privacy, not only at, Joanne has talked about, not only at the code level. When we are having the services deployed at cloud, what is the security we are providing at the API level? That then attacker who is trying to consume my model, trying to get the interpret of my model, are able to get the data back. So do we have those systems? Adversarial learning. Then integrating, having the Kubernetes pipeline in place. It's SEO. How do you manage the pipelines? Container registry, where you are creating the images. Google's container registry. So it's not possible to put all the tools in place. Google's container registry, you create an image for a specific hyperparameter tuning, for a specific run. Then store the image in the container registry. Tomorrow you have done another hyperparameter tuning, and your model has reduced accuracy. So go and refer back to the previous model. Store all your images in the container registry. AutoML, even if I don't know AutoML, use these 5 steps to get my model into production. So current challenges on productionizing ML. So on the production side, we have scalability, availability, portability, reproducibility, of course, modularity, security, and hosting serverless services. And on the ML challenges, we have governance, continuous training and deployment. Are we improving my model continuously? What are my model metrics yesterday? And I'm having 3 data scientists working on it. So have they done something different which has improved my model, or they are gone only researching last few days? How do we track that? How do we track V1 versus V2, model V1 versus V2? Are we employing the right tools? Data validation, model analysis, fairness, and explainability. We'll cover this fairness and explainability, as well as the analysis part of it. So how many of my time is correctly invested in developing correct models which are stored, can be reused tomorrow by my team, and we bring in features stored together with it by another team? How we are having that ecosystem for enterprise AI setup. Because if you see, 70% of the machine learning models that we build are on laptops, or even they are on clouds, they don't go into production. We are not able to productionize them because we don't see valuable metrics coming out of them. So if I tomorrow trying to convince my customer that adopt Google Cloud or any other cloud provider, how I'm going to convince him that this is this model and this is that it adds value to your business? Not only the model metrics, not only precision, recall, or for clustering metrics, your select score, But what value does it add to your business? How do you explain that question to business? Yeah, so I think this has been discussed many times, not going into details. So you look at, not only you do your exploratory data analysis with notebooks, Google Cloud Visual Studios and all, you prepare data, manually prepare the data, do feature engineering, training, and finally productionize the model, so that it can be consumed by an API. API, you can deploy it in a Kubernetes pod and see, monitor how it is getting auto-scale based on your number of requests. Now, here it comes the most important challenge when you rewrite the productionized code. Have we followed all the right parameters that each and every line of code should have to capture all the model metrics, model profiling, how much time is it taking, or which step? Are you following the best practices which should run in production? Are you doing do you have the right interpretability tools in place? Are you able to explain using what-if analysis whether your data is biased or not? What if your data has a small section of minority population and it does not have the the racial section? So you have a lot of data on the white population. You don't have Hispanic, Asian population. And now you're telling that Hispanic or Asian are prone to this disease. Does it make sense? Or what you should do at that time? How do you generate synthetic data? What are the tools available? You know, minority sampling, majority downsampling, adaptive synthetic sampling, imbalanced data. And on those imbalanced data, are you checking the metrics, right metrics, whether your precision recall works for the entire overall ML solution or all for those minority sections also? If not, what are the right mitigation strategies that we should be bothering about? Can we go back and tell to business that? We should not. Ideally, we should not. We know there are problems. We should be transparent and explaining that to business, to my clients who are looking for digital transformation. Now, use Google Cloud as well as marry open source. Why? Google Cloud is already in partnership with so many open source tools and organizations. Elasticsearch, index-based search. You want to quickly build a dashboard and see how it is working. You have a Kafka pipeline. Then you put your analytics tools in place. Elasticsearch, Influxo.io, Neo4j, you want to do graph analytics, graph database. So put that directly into Google Cloud, those open source, very specialized things what you want to do that you may not like that the tool which Google is providing, or you're exploring new capabilities. Integrate with that. Redis. So the amount of in-memory processing that you are looking for is not possible with a standard database, not SQL or no SQL database. What do? Integrate Redis directly into Google Cloud. Build Confluent. Build your logging monitoring pipeline, and then and integrate with Superset. Superset DBs, open source. You are not paying anybody anything. Prometheus, Datadogs you need to pay. Then integrate those tools. And have a quick visualization at how it is looking like. Your cost, look at the KPIs for model, as well as look at your KPIs for cost. Of course, you are not paying for the monitoring metrics. These are open source. You are maybe paying for the VMs that's running, or the pods that's running, the Elastic Kubernetes engine that's running. Use Fluentd. You want to collect access logs, app logs, system logs, everything that is going on when your machine learning model is running, as well as your application is running, Cloud Run is running. It's not only ML, but at the end of the day, we are doing ML to give some insights. So there are APIs. So how do we capture those? How my system is behaving? Of course, we have load balancer, we have dashboards, and we are seeing everything. But code level profiling, I'm writing each and every line of code. Are they robust enough? What is the time spent on each line of code? So integrate all those tools. Logstash, open source tool, just to pump your logs from your microservices to a visualization tool, or to the agent, or to the server, where you will have to look at where it got wrong. And integrate all the open source tools for machine learning. Whether you are building a vision application, or you are building OpenCV, NLP-based BERT models, or FastText, then AI for mobile, TensorFlow, Lite, Keras, Caffe, Theano, or scikit-learn type libraries, PyTorch, or TensorFlow. Or even in these libraries, you are trying to integrate separate interpretability tools like Shapley, Lime, or deep learning interpretability tools. Go ahead. Each of these units, you go and add interpretability tools, or you add privacy tools. You want to check the code injection, any harmful code has been injected there. Go ahead. And this gives you another tool to integrate your tracking or model governance. This is the model DB you can use. You can use MLflow. Just you need to initialize a single line of code to initialize your server and track which experiment of the model you are doing currently. So it will be tracked like experiment 1, experiment 2, like with the different hyperparameters, that random forest with this kind of tree depth, and this is the maximum number of splits of the random forest. This is the score. Track your models, improve, and track your team's performance. So if you're a leader and you are trying to get your effort analyzed at the team level, try to do that. Then we have MLflow also, a kind of a model DB tool. Track your experiments. It's very simple to launch with your Google Cloud. You have to specify the MLflow server, at what port it will run, and then start running it. And at the specified, you can specify a directory at S3 or somewhere else where your logs will be getting stored, and you need to pull out the logs later on. Or you have to visualize with the dashboard. That is, I've shown you the previous slide and this slide, how the dashboard looks like, how the metrics look like. We have talked about model drifts and the pandemic, how badly it has affected the banking industry. Even the retail, if you see that most people have started moving to online, as opposed to going to physical store, going to the stores physically. Use a scikit-learn tool. Change where all in your data the patterns changes. Drift, detect the drift. There are numerous examples of that in using SK Multiflow, and other examples are also there, which will help you to monitor the data drift, how the data pattern has changed. Or is it the data remains the same, the model has changed, because the dependency between the X and Y were correlated before, it's not now correlated. Something has changed, or the linear correlation has gone to a higher level of correlation, which your model is not able to detect. Linear models are not able to detect. You have to move on from linear logistic regression or linear regression, you have to go to SVM. So how do you detect that? Your model drift will tell you now this is not going to work anymore. So you have to change your models, or you have to retrain your models. So detect the drift at the first place. There are innumerable tools or libraries to detect drift, and different mechanisms to detect drift. Yeah. Now scalable enterprise platforms using Google Cloud, of course, Vertex AI. It has been covered before also. There's nothing new to cover, but just have a look at all the different units, just from labeling to feature store, which I would like to stress, using Feast. You can go into the open source Feast platform, check it out, or you can contact me also, how Feast runs. Then prediction, explainable AI, hybrid AI, monitoring, metadata management. We will talk about metadata management using the data catalog. Hyperparameter tuning, all this is provided by this Vertex AI. Pipelines. You want to create dynamically pipelines, you have to just change how your pods are linked, which microservices. You are doing it through different types of microservices or different units, that the TFX pipelines we will call. That is, even you can run it through Vertex AI. So this is how you can go on and add your own unique customized blocks or units that will help you to run the experiments. So today you have data transformation 1, tomorrow you want to add data transformation 2, you want to bifurcate because for this type of data you add this type of data you add this, do normalization, feature scaling, add model training, ensemble models, add it through pipelines. Track the artifacts and go for serverless deployments. Yeah. So Vertex AI has given us a unified platform, not only for custom ML models, but for auto ML. A person who has joined, or say an intern who has joined new, and may not be aware of the details of what machine learning would work better for this, for our higher dimensional features. Say for SBM, we have to first start the analysis. It's not a linear model. Start with auto ML. See what works and what doesn't work. Again, how it works, you can even take a Vertex AI feature store, deploy the model, have the prediction serving, and when you are serving the model, look at the serving logs. Maybe for a particular instant, at a particular unit of time, when there were a lot of requests, think about a campaign you are running and for a retailer, and that has a Black Friday sale, or it has a Christmas sale. See how your graph looks like. There would be a sudden burst. Is the model predicting correct at that time? You have tested it, system tested, you have tested, unit tested it for certain units of time. But have you tested it at that unit of time? What are the metrics you are getting from the model as well as your entire latency of the system, end-to-end latency? Look at the logs. Sometimes I have seen one personal experience based on using this. It is timing out. We had no clue why it is timing out. It is not able to answer to that within a request. 3 seconds, even it is timing out. And your cost is increasing because this is all pay as you go. Our cost has risen 3 times. So we try to find out, and they said even if it's timeout. And then when we looked at our systems, we found out from the logs that some of the data which we were expecting from the customer is not there. And our model is that it is not that robust. We have used that data to do our predictions, but the data is not there. It has been logged as exceptions, but the data for training and prediction is not there. The prediction is using the correct data from that unit, which should be there. It's not there. So make your story, what is working, what is not working. Then similarly, we have known that TFX pipelines, I think many of you have seen before, we used to run TFX customized pipelines, but now we have that as an evaluator, trainer, and serving, that all you can run within Vertex AI. That gives you a platform to do everything. How you're creating are you doing a training, or you're pushing your model, you want to push your model to container registries, store them, pull them out, run it. So everything is possible now through your Vertex AI. And now going into a very limited time left, we'll go through responsible AI. So sharing and collaboration, we have talked about feature store. Now how it works is you have the data lake, you do the feature engineering, you have either batch feature ingestion or streaming or live data online store, you are doing the live learning model training. You are serving your models. And while you are serving your models, you can again do the same thing running in a parallel setup, doing the feature discovery. While predictions and as the new data comes in, there could be new features that are coming in. How we do the feature discovery. The feast helps you to do, the feature store helps you to do. Something which is changing in the data pattern. And that, remember, our objective is to reuse things as much as possible to other teams. Let other teams know. Subscribe, have a cloud pub subscribe to your engine so that everybody is getting notified about the new feature which has been discovered. Yeah. So as an enterprise system, what are the basic building blocks you should have? So explainability, and having that involves you have a well-defined ML model, and you can account to your business, being transparent, and it's not everything can work alone as an automated system. There are humans who are involved, human in the loop, human on the loop, who are monitoring and and DevOps professionals or MLOps professional who have the notifications. You have to subscribe to notifications like Slack or email that something goes wrong. Immediately DevOps are notified, and human in the loop are aware what's going on in your system. And that helps us to build like solutions which are non-biased, and that is able to give fair predictions to exclusive of gender or race gaps with speed and agility. Here you see how having explainability has helped you to determine pen marks by a doctor. So X-ray has revealed something, and why that has been revealed is nothing but pen marks as opposed to a tumor or a cancer. That's what is explainability. And that's why we should use Shapely, Lime, or you can, even for the data part of it, if you want to know how much your data is biased or non-biased, you use what-if analysis tools from Google Cloud. So here, there is a data simple for an insurance industry that says that how much premium you should be paying, and what are the factors that is driving you to pay more premium. Whether it's age, or you are already a risky driver, you have incidents of accidents in the past. This is a simple what-if tool that helps you to select your features and run the model and see that where is the problem with the data. What all features are creating the problem? Means what are the features that you should have more that you don't have for certain sections of the population. If you want to know more about explainability, here is the way that post hoc explainers that you can use. That is, after your model has given you some outcome, or interpretable models. Simple by, which is explainable through design. Now you have model-based constraints, means you can explore TensorFlow constraint optimization. So in a regression model or in a classification model, when you are having that objective function, how do you have the constraints built in? When the model gets trained, you have that along with your constraint, the optimization function comes to a convergence. Now, all these things, feature-based, database, you can understand confidence-based, what's the confidence you want to have on each of the features that are going for the model training. And you have counterfactuals is important, like proxy features. Some feature which is directly not giving you a biased model, but it is dependent on some other features. Suppose I have removed gender, male or female, but based on the gender, I see there are more engineers in male than female, because male receive more opportunities in our society as of now. Now, that feature is contributing to the annual income. So how do we find out that? So counterfactuals, feature counterfactuals, proxy features, which indirectly helps you to find out how your model is getting biased. Okay, decision rule, in reinforcement learning, also rail-based data valuation, like policies. How fair are your policies, control group policies that you select for reinforcement learning. So these are the tools available, where you can use explainable AI, whether you are using at an application level developers, ML APIs, AutoML, BigQuery ML, or you are going directly into your TensorFlow models or AI platform notebooks. Have each instance level feature explanations that you can talk to business. You can explain your BI, or you can even explain your CEO. And then you have a local SDK to get explanation without even deploying your model. You are building a risk mitigated system? What are the testing tools and frameworks you have in place that you can explain that? In Google Cloud, how you do that? Yeah, if you are not doing that, we will end up in having so much biased models, like error rates for dark-skinned women. You can see that it is for 20 to 34%. We will continue to have bias in our society. Going to the next digital transformation, which we are expecting with blockchain, we have the ETL topics, the data engineering pipeline running it. Get the data of all your transactions, Bitcoin-level transactions, from whether you are using Hyperledger or Ethereum, whatever is the protocol, get it flow through BigQuery, or through your CSV files or pipelines. You can explore what is Airflow, what is Cloud Composer, a lot of things. These are nothing but DAGs. which get chained together, when I direct acyclic graphs. Have them on the BigQuery, then you answer all those questions, like why we are using blockchain, and how much responsible is. By responsible, I mean these factors. How much transparent it is, how much decentralized it is. Are we able to not remove central dependency? Are we able to audit our transactions? Because in blockchain, you will see one major factor is immutability. How do we have all these things inbuilt through Google Cloud? How do we build the entire pipeline starting from getting the financial transactions on blockchain? So here you see we need a data catalog. Blockchain is nothing but P2P node. And that you have this data catalog which can be used, how it can be used, centralized data catalog, whether you're using cloud storage, cloud PubSub, or BigQuery, or you are trying to sensitize your PII data. That also get into data catalog. Discover more about your data, metadata. What are the business glossary terms that could be useful? Take a track of all these things. And if you see that the going digital during pandemic, COVID-19 pandemic, how the federated learning discovered by Google, how it has played a major role in determining how severe the disease is, whether I would need ICU or I will need oxygen supply. So you have to explore more on the hybrid type of privacy systems. Differential privacy, that is an application privacy underneath the platform security rules and privacies. Not so much time, but this is how differential federated learning works, and how we need privacy when the nodes send out data to the model, aggregate the model, the central server aggregate the model, or how do we send the weights, how do we send the model data from the individual nodes. All this needs to be taken care of. And Google has promised that we will go carbon neutral by 2030. What are the plans? So cloud is providing us to measure the CFE, and there are several other metrics you will see. Now, as an organization, I'm using Google Cloud. Am I following those metrics? Am I using those metrics and setting it goals to my individual teams that you are developing ML models? Well and good. If it is not needed, are you still using deep learning pipelines? If not, then move to traditional machine learning. That is not going to consume so much of energy. What are the metrics that we are going to monitor? The CFE percentage, amount of carbon emission. Even if we are emitting carbon, what are the policies that my organization is following to compensate that? Are we using renewable sources of energy? Are we planning business for investments on renewable energy? Because my solution is doing that, Google is doing that. Who else is doing that? Can we bring around those conversations so that we can save our planet? Yes, some of this is look for run batch jobs. What are the mechanisms that as an engineer we are doing? Run batch jobs. Have the emission metrics, move to infrastructures which is less carbon, more carbon friendly. Like instead of choosing Frankfurt, go into Finland, go to Sweden, have your data centers. So are we considering those options? And then the last slide is there. You can see the slides, how much cost per sustainability, how we are balancing the trade-off, how we can reduce the price and increase the CFE. Are we doing those trade-offs while developing my application? So are we choosing North Virginia, or we are choosing Oregon or Los Angeles? Because more applications around US, more businesses around Los Angeles. Many people have hosted in that data center. So conclusion, I have the last slide. Conclusion. So as we move on as a startup or at a middle-level organization to making transformative changes, what are the things we should be looking at? We are starting with POCs, but as we are going to be more opportunistic to making differentiated services, We have talked about what are the different tools and technologies we can use. Data, Vertex AI, data proc, explainability tools, what if analysis, sustainability metrics. That has to be also married to the organizational business objectives. It's not that I become selfish and my business is yielding value, but I am doing a lot of harm to the environment. So as a whole, how matured is my system in giving values to customers, as well as being responsible for the environment? Yes, thank you. So questions? Yeah, please.
Hello. Ma'am, you mentioned about data drift. So what are the ways of detecting the data drift?
So data drifts, you can, first of all, you have to detect whether it is a real drift or a virtual drift. Sometimes it may happen that you are seeing the data, the model decision boundaries remains the same, but it is twisted a little bit. So you have to understand whether it is an actual drift or not. Then you can go into and explore on the different ML techniques. Tree-based methods are there. Where you see, or there you use a root node of a tree, where you see the change is maximum, you stop at splitting the tree, and they understand the model drift. Some are mechanisms are understanding the stream. You have taken windows, and from a particular window to the previous window, how much the data has changed. Then you have to determine that how much of the previous history you will take, and how much of the recent history you will take. Then what is the percentage of drift, and how do you recommend, what is your recommended approach to remove the drift? You can write a custom algorithm, or you can use time windows based algorithms to capture, to retrain your model.
Okay, thank you, ma'am.
I am currently working on a research paper that uses ML to distinguish between the lungs of a normal human and the lungs of a COVID patient. So could you please suggest some ways in doing so, as the training modules of the are a bit tattered?
Yeah, so you are using some, computer vision, right? Or you have also data for...
Yeah. But
yeah,
the data sets are a bit not...
yeah, if it is a computer vision model, I am not a vision specialist, but I will try to answer from my point of view. So you have to use different types of convolutional networks, and what kind of filters that you are going to use. That plays an important role to discover features within features, not only at high level, because high level it will be, everything will remain similar, but at the lower level, if you are able to determine something through use of filters, and then if there has been somebody who has already trained some things, use transfer learning, change that. And otherwise, if you have data, like if you have lungs data, means real numbers, you have to see, do you have any? Analyze the patterns. You have, other than vision, any other data?
we just have the photographs of the X-rays.
Then you have to rely on convolutional networks and filters to analyze the data.
Okay.
Any other questions on ethics, sustainability?
Hi ma'am, I'm Shayok. I wanted to ask that, like, for a legacy company, like you said, oil and gas, what could be the possible challenges while performing the ML management flow?
Yeah, so one of the highest possible challenge is to getting the data, because there will be sensors, right? So getting the sensor data and keeping it private, and then integrating the data. So that itself is a great challenge, because you have to again see from the timing perspective, when you are collecting the data, all those clocks have to be synced, and when you get in the data, you have to maintain privacy, all this data, because they run out of power. This device is run out of power. At what intervals that you want to schedule the data updates to them. And once you have it in place, do you have all the data, synced data in place, or you are getting one sensor, two sensors are side by side, you are getting one data which is 5 minutes lagged, another 5 minutes. So something has happened in between. So how do you interpret that? What is your best suggested mechanisms that will be able to capture data from there? Yeah, once you have that, you have to go by federated learning, one of the mechanisms for IoT and all. There also, when you do the application level learning, Do you have privacy? Or when you are transferring the weights and biases to a central server, what kind of algorithms are you using? Are you opportunist or you are pessimist? Suppose you are opportunist, then you are looking for fast convergence. I want an aggregated model. And if you are not you are pessimist, you are waiting with all the clients will sell me the updates. All the clients have sufficient energy. They send me the updates, and that time I will converge. Your model may take time. So what is your business looking for? Do they want quick changes, determination? Then you have to fix, make a trade-off between the timing and the energy availability of the devices.
Thank you, ma'am.
Yeah. Yeah, references? Yeah. Yeah. So the next book is coming out in 2023. Platforms if you want to explore more on ethics or sustainability. Any
Yeah.
other questions? Yeah.
I am Suman. So you talk about the carbon emission. So when we push the code into production, normal developers don't do think much about the carbon emissions.
Yeah, there are code carbon emission trackers. It's an open source tool. Integrate with you in your code, and once you train your deep learning, mostly for deep learning models, for I don't think you are doing for XGBoost, but if you can, it's of course good. Integrate that in your code. It's an open source tool, and have this check on what's the emission. And if you're changing something, you're changing some of the hyperparameters or cross-validation sets, iterations, how is it affecting it? Is it really necessary? You have put 100 iterations, or are you using early stopping?
Yeah. And so are we doing, like we are doing enough in the institutional level? You talked about the organization level, but I'm talking about, are you doing enough in the institutional level? Like,
That you guys will tell me, I think.
okay. Okay, great. So that's it.
That I think somebody can answer from the audience that are we doing enough from the institutional level?
I don't think so.
Later, okay, thank you. Okay, thank you.